So example, if we have hexane dioic acid, so carboxylic acid will lose its OH and amine will lose its H. OH and H, this result in a formation of, this is a amide linkage or peptide linkage. Same thing, a common polyamide, which is Kevlar, used as a bulletproof vest. So it contains dicarboxylic acid and diamine, but these are aromatic compounds. You can see a benzene ring is also attached. So carboxylic acid will lose its OH and amine will lose its H. And there will be amide or peptide linkage. So there is also a possibility that identical monomers can lead to a formation of a condensation polymer. But for this condition, the polymer should have the reactive group both sides. The monomer should have a reactive group both sides, which can react with each other. So what happens, like example, if we have a compound, one side acyl group is there, another side OH. And as we discussed, the acyl can react with OH. One side it will lose its H, another side it will lose its Cl. So if you want to complete the formation of this product, the polymer, so another molecule, this is also a monomer. So what will happen? One side it loses its H, another side CH. One side loses H, another side it will be CH. And the final polymer will be, because this H is removed, so there will be O, then CH2 in a bracket 3, and then C double bonded with O. The Cl is removed, and then there will be another O, then CH2 in a bracket 3, and then C double bonded with O. Is it clear? The formation of a polymer by identical monomers. Any doubt in? So this is just for practice, because you don't have to memorize this. The main thing is, in exam, it's not necessary that you will have the same question to draw. And directly, they will not say draw a polymer. They will give you a monomer, and you have to draw the polymer. So it's just the concept which is important rather than copying all the polymers. So when we compare these chemical reactivity of the condensation polymers, so polyesters and polyamide, if a polymer can be broken down by a water molecule or aqueous acid or aqueous alkali, the process is known as hydrolysis. So these condensation polymers, because by the help of the water or by the help of aqueous alkali or acid, we can break these molecules, so we call them as biodegradable. So polyester can be hydrolyzed by acid or it can be hydrolyzed by alkali. So advantage of these biodegradable polymers is because it will not produce too much rubbish because of all the plastic waste compared to normal polymers, which the addition polymers are there, and we are making these polymers from the main naphtha is there, the main ingredient for that, or condensation addition polymer of ethene, which make a polyethylene. So they are not biodegradable, does not decompose or broken down by chemical reaction. So if you want to hydrolyze the polyester, it can be hydrolyzed by acid or alkali. And if you want to hydrolyze a polyamide, it can be hydrolyzed by acid or alkali as well. But what will be the result, the formation? If we hydrolyze the polyester with hydrochloric acid, it will split up into dicarboxylic acid and diol, the original product. But if we hydrolyze with sodium hydroxide, it will produce a diol and dicarboxylic salt. What is the reason? Because when you have polyester which is formed by either a dicarboxylic acid and diol, that carboxylic acid can react with sodium hydroxide. That's why it is forming a salt of dicarboxylic acid, not exactly dicarboxylic acid. Same thing if we have polyamide and we hydrolyze them. So if hydrochloric acid will be used to hydrolyze them, it will be split into original dicarboxylic acid and diamine salt. But if sodium hydroxide is used, it will be diamine and dicarboxylic acid. Salt will be there. What is the reason? Because if we use acid hydrolysis, so how polyamides are formed when carboxylic group is there reacted with amine group. So the result will be carboxylic, C double bonded with O and OH, and amine group is there. If we are hydrolyze this in the presence of acid, so the acid which is present after forming the amine, that acid can react with amine. That's why it is producing an amine salt, and dicarboxylic acid will be the product. But if we are hydrolyze this in the presence of sodium hydroxide, so sodium hydroxide is an alkali, so it will not react with amine, it will react with carboxylic acid. That's why the dicarboxylic salt is there, and amine will be the product. Is it clear? The resultant product for hydrolysis of acid hydrolysis of the polyester and alkali hydrolysis of the polyester. And same thing, acid hydrolysis of polyamide and alkali hydrolysis of polyamide. Any doubt in this? Any doubt? Is it clear?
Clear.
Copy the highlighted part. Okay, the next part. Then the intermolecular forces or the force between the polymer. So intermolecular forces between the condensation polymer chain. Example, if it's amide linkage or peptide linkage is there, so it contains C double bonded with O. So C double bonded with O, this means there is a permanent dipole. So due to this, there's a permanent dipole. NH group is there. NH group, when nitrogen, hydrogen attached to nitrogen, oxygen, or fluorine, then this result in a formation of a hydrogen bond with another molecule. So due to NH, it can form hydrogen bond. And because in the system, there are a lot of electrons, and these electrons, like example, the benzene ring here you can see, or a carbon chains will be there instead of benzene ring. So these chains also have attraction. So it will have all the three type of force. The hydrogen bonding will be there, the permanent dipole will be there, and London dispersion force or van der Waals force will be there. Is it clear?
Yeah.
Next is the amino acids. You don't have to, the previous part was actually just identifying the types of the forces present. Next is amino acid. Why we call them as amino acid? Because they have amine group and they have carboxylic. That's why we call them as amino acid. And the simplest amino acid, the general formula for any amino acid, like NH2CH, the carboxylic, and then what is R? R can vary from like different amino acid. It have different chain length or different alkyl group. The simplest amino acid is NH2. When instead of R, if there is H, so NH2, CH2, and C double bonded with O and OH. Where in this case, R is equals to H. How to name these amino acids? The naming of this amino acid. You don't have to learn the actual name. You have to the standard IOPIC system we will use to name these. So when you count the number of, so this one is 2-amino. Why we call 2-amino? Butane dioic acid. So what is the reason for that? C double bonded with ON OH and C double bonded with ON OH. So we select the carbon chain. So when we select the carbon chain, this is the longest carbon chain. Numbering should start from nearest branch. So in this case, if I count from here 1, 2, and 3, so third position I will have a branch. But if I count from other way around, so 1, 2, 3, and 4. So second position I have a branch. That's why I called 2-amino. Why but? Because there are 3 carbons, so I'll say but. They have a single bond, I say N and ANE, but we'll not write AN only, we'll write ANE because when we use the term di or tri, it should be ANE, the full. Then how many carboxylic groups are there? 2 carboxylic, so that's why it is dioic acid. If you name the second one, so 1, 2, and 3 carbon atoms only. And this carbon is our first carbon. So 1, 2, and 3. So second position we have amine group and third position we have hydroxy. So 2-amino, 3-hydroxy, propanoic acid. The common name, you don't have to memorize the common name. You should know how to write the IOPIC name. Same way, this is our first carbon. So second position amine group is there. So it's 2-amino, ethane, H because of 2 carbon and single bond, and oic acid. If it was dioic acid, then we'll write ANE instead of AN. And for this, aspartic acid is there. So, or how to name this one? This is actually aspartic acid is 2-amino butane dioic acid. So how we name this one? So C and then 4 carbon, so that it makes 6 carbon, and we number 1, 2, and then the last one. So second carbon and the 6th carbon contain amine group because this is CH2. Bracket 4 means there are 4 carbon atoms there, and at the last amine group is attached. And COOH, that's our first carbon. H is there, and NH2. So 1, 2, 3, 4, 5. One more should be there. So 6 carbon atoms. I did not draw hydrogen with them. So this is the second carbon and 6 carbon. So second and 6 carbon contain amine group. That's why we say 2,6-diamine. Amino, basically it's a functional group here, so amino. Hex, because there are 6 carbon, we say hex. And oic acid because of carboxylic group. Is it clear? Any doubt in this?
No.
So the journal formula for the amino acid you will write, and the name, just copy the name, not the rule. You don't have to copy this because you can identify the technique from their names only. So how these ions exist, like amino acid basically exists in. So these amino acid, as you know, what is the tendency? Because there is a lone pair on the nitrogen. And what is the tendency of acid? The definition acid are proton donor. So they want to lose the proton. And what is the tendency of the amine group? It is a proton acceptor. So when acid will lose its proton, amine will accept that proton. So as the amine will accept the proton, so already NH2 is there, a proton is accepted. So what will be the charge on the amine? It will be positive. And what will be the charge on the acid group? Because it lost its proton, so C double bonded with O, and O is there. Oxygen took the electron, which was shared between oxygen and hydrogen. So this will have a negative charge and this will be positive charge. So these amino acids exist as a zwitterion ions. So net charge is zero. There is no net charge. So amino acids are often solid. Why they are solid? Because what happens, these molecules, when one side loses proton, another side gain proton, so it create a charge. And force of attraction between the charges will be stronger. So another molecule will also have a charge. And as these charges are attracted towards each other, this result in a formation of a strong attraction or a bond between the molecule, which makes this amino acid solid at room temperature. So there's an ionic interaction which explain why the amino acids have high melting point as compared to the other groups. And the acidity or the basicity of the amino acid, the term acidity means tendency to lose proton, and basicity means tendency to accept proton. So these amino acids, it depend on, like example, this is a normal molecule of amino acid, but how they exist, there's a loss or gain of proton. So one side will be positive, other side will be negative, and this happens for other molecules also. So they will have a strong attraction between the molecule. And which ion will exist? Like example, if it is in alkaline medium, so if it's in alkaline medium, alkali means there is OH. So what is the tendency of OH? OH tendency to accept proton. So when OH will accept proton, so the proton will be lost from amine group, and what we are left with? We are left with NH2 C double bonded with O. So in alkaline medium, this species will be more. But if in acidic medium, acids have more proton. So what will happen in acidic medium, as there are more protons are there? So C double bonded with O, which already lost that proton. But what happened, because if it's in acidic medium, so there are too much proton, so that proton will return and we will have NH3 plus C and COH. This is a proton which is accepted by the C double bonded with O and O which initially lost. So in acidic medium, what we have more? We have more this ion. In alkaline medium, we have the other ion more. But normally in a neutral medium, neutral solution, we have a zwitterion ion which contain plus and minus charge on the molecule. Is it clear?
Yes.
So for amino acids, the question is why high melting point? That's the reason. And which ion exists more? Depending on the pH of the solution. So only copy the highlighted part. Then identification of these amino acids, we can use a chromatography. A chromatography can be used to identify these amino acids. So example, if we have a mixture of amino acid, we can use a paper chromatography to identify them. Each amino acid is having its own RF value, and using that RF value, we can identify which amino acid is present. Then what happened in this paper chromatography, we place a sample on the origin, we use a suitable solvent which can dissolve, and we use a locating agent because these amino acids are colorless liquid, so that it make a salt, this amino acid visible. And the distance moved by a spot to a distance moved by the solvent, we can identify the RF value or measure the RF value and compare. The second thing is the optical activity. the optical activity of the amino acid. So all amino acid except the glycine, which is the first one, sorry, the second one, it's are chiral because there are four different groups are attached. So example, why this this amino acid is not having, why this is not having an optical isomer, because to have an optical isomer, the atoms which are attached with a carbon should be four different atoms. So if it's W, X, Y, and Z. But in this case, because two hydrogen are attached, so if two identical groups are attached, the carbon cannot be a chiral carbon. So this is not a chiral carbon. That's why the first one, except glycine, they all have a chiral carbon, which result in a formation of a optical isomer. And how to draw an optical isomer? Like example, if I say you want to draw an optical isomer of this amino acid, so example, you place a mirror in front of this. So when you place a mirror in front of this, so this will be H, O2 and C. Then the central carbon, this hydrogen is up, this group CH3, and then NH. So these, they cannot overlap with each other. As they cannot overlap with each other, they have different tendency to the polarized light. One can rotate clockwise, another one can rotate anti-clockwise. And if we have a racemic mixture, a mixture which is having an equal ratio of the two enantiomers, then it will not be, it will not rotate the polarized light. So these, they will have a similar chemical and physical properties. The only difference is the tendency to react or variation they show with the polarized light. Is it clear?
Yes.
Then the peptide dipeptide. This part I want you. Uh, this was about the amines, amide, and amino acid. I will share one more thing, the new topic, which is so copy this part for only the optical activity part, because the chromatography they don't ask to write experiment. It's a very basic question. Optical activity part, right? Just a minute, I will start the last topic, which is about the synthetic routes. So synthetic route, it's actually what you studied till now, the reactions is refers to the synthetic route or manufacturing routes. So this is one complete slide about how one reagent, one substance can be changed into another. This is just a revision rather than you don't have to copy. I will share these slides also with you. So you can copy later from that. But right now you don't have to copy this. Just explanation. Example, if we start with alkene. So if you want to convert alkene into polyalkene, like polyalkene or polymer, so what we should do, what are the reaction conditions? So it should be high pressurized catalyst and the reaction is polymerization. If we want to convert alkene into dihalogen alkane, means we want two halogen as a substituent groups. So we should use either bromine or chlorine at room temperature, and the reaction is electrophilic addition reaction. This mechanism you took in AS chemistry. Or if you use potassium manganate 7 as an oxidizing agent, alkene will form diol. That's also a reaction of AS chemistry. Or if you have dihalogen alkane, you react with potassium hydroxide, aqueous potassium hydroxide, and heat under reflux. Nucleophilic substitution reaction will occur, and that will also result in a formation of diol. If alkene is there, you use hydrogen you use hydrogen as a reagent and nickel as a catalyst. That will result in a formation of alkane. If you use hydrogen bromide or hydrogen chloride at room temperature electrophilic addition, this result in a formation of halogen alkane. Or alkane react with bromine or chlorine, it will also result in a formation of halogen alkane. Halogen alkane, how you can convert into amine? You react with ammonia, it will convert into amine. Then amine, if multiple substitution occur, it will be secondary amine or tertiary amine. Or if you have a secondary amine, you react with acyl chloride. If you have amine, the primary amine, you react with acyl chloride, so it will form secondary amide. Amide means C double bonded with O group will be there, and NH2 group will be there. Or if you have halogen alkane, you want to convert back them into alcohol, so you can use potassium hydroxide and heat under reflux, it will form alcohol. Or if you have alcohol, you react with PCl5 or PBr3 or PI3, it will form back halogen alkane. If you have alcohol, if you use an oxidizing agent, alcohol oxidizes to carboxylic acid. If it's primary, first to aldehyde and then aldehyde oxidized to carboxylic. If it is secondary, it will directly oxidize to ketone. If it is tertiary, it will not oxidize. If aldehyde is there, further oxidation will give carboxylic. Carboxylic groups, if you react with PCl5, it will form acyl chloride, or carboxylic group, if you react with alcohol, it will form ester. Or acyl chloride, you react with alcohol, that will also form ester. If you have ketone group, you react with mixture of hydrogen cyanide and potassium cyanide. It is a nucleophilic addition reaction, and it will form hydroxynitrile. Is it clear? So basically, this is the whole chemistry what you took in AS and A2. All the reactions of organic chemistry. This is just a summary of this all. So if you learn this, all the reaction mechanism are also mentioned and the reagent are also mentioned. So you can form any. So if the question is, if I say I want to prepare amine from alkene. So if I want to prepare amine from alkene, so amine, first I should react with hydrogen. Alkene, I should react with hydrogen bromide and chloride from halogen alkane. And this halogen alkane react with ammonia, heat under high pressure. It will result in a formation of amine. If I say from alkene, I want to prepare aldehyde. So alkene, halogen alkane, then halogen alkane to alcohol, and then alcohol to aldehyde. Any doubt in this? This is a whole chemistry reactions which you took both in AS and in A2.